Okay, you're welcome to FEMSA Medical Consultancy channel. The other video we attempted question number 2B of 2015 of Jupeb past question on trigonometry. So today we'll be looking at question 2C of the same year 2015. In that particular year there was no question on the objective as regard trigonometry. So, and it's very important that you get every necessary mark you need to get to be able to, get the maximum mark for the desired course of interest. So we'll be looking at this particular question now. That's question 2C. That's 2015. Question 2C. It's a theory question. The question says that if sine A equal to 4 over 5 and cos B equal to 12 over 13, where A is obtuse and B is acute, find without using tables the values of Roman figure 1 sine A plus B, Roman figure 2 tan A minus B. All right. The question says if sine A equal to 4 over 5 and cos B equal to 12 over 13, where A is obtuse, that's referring to the angle. Where when the statement says that A is obtuse, that shows that angle A is an angle that is greater than 90 degrees but less than 180 degrees. And B is acute. That shows that angle B is strictly less than 90 degrees. So we are to find without using tables, that means the statistical table, to find the values of sine A plus B and tan A minus B. So here, to be able to solve this problem, we will still need to make use of our addition formula. Okay, but it's very important, this statement, the condition of this angle A and that of angle B. Okay, solution. Now, so that it will not appear to you as though I assume you already know what we are doing, let's look at what sine A plus B is meant to give us from our addition formula. You recall that for Roman figure 1 now, sine A plus B is to give us sine A cos B plus cos A sine B. Sorry. So now, from this expression of this sine A plus B, which is sine A cos B plus cos A sine B, from what we have been given, we know sine A, which is 4 over 5. We know cos B, which is 12 over 13. Do we know cos A? No. Do we know sine B? No. So how are we going to get it? Don't panic. It's very easy. Now, that's the reason they gave you. We need to take note of these conditions here. If angle A is an obtuse angle and angle B is an acute angle, how can we leverage this information to get this unknown trig function of A and that of B? It's very easy. So all we just need to do, there are two ways. Some people may decide to sketch a right angle triangle to use that, because we know that if this is sine A, by definition of sine of an angle, which is the ratio of the opposite to the hypotenuse side, definitely 4 is going to be the opposite side and 5 will be the hypotenuse side. But rather than sketching a triangle, a right angle triangle, you can as well use your identity, trigonometric identity. So now look at it. I'll say recall that sine square theta plus cos square theta is equal to 1. Now, that theta there is arbitrary. It can be any value. Because it's an identity, there is no value you put there that will not satisfy the equation. Okay, so permit me to make it easier for what we are doing. Instead of using theta, I want to change it to sine square A cos square A. I will still get the same thing. Alright. Because it's an identity, this equation will be true for any value of this A. So, don't forget my duty, I already know sine A, but I don't know sine B. So, that means that, and I also know cos B, but I don't know cos A. So, from here, look at it, I can say that my cos square A is the same thing as 1 minus sine square A. That's if you subtract sine square A from both sides, you have this equation. So then what is now cos A from here? Cos A will become, take the square root of both sides, because when you take the square root of this, you have cos A. Then the square root of this will become 1 minus sine square A. Now, it's very important that to take note that this is an even root of this expression. So whenever you have an even root, your results will not only be positive, it will also be negative, because it's an even root, such like 4th root, 6th root, 8th root, and the likes. So even root of an expression will always give you an answer that contains the positive and the negative value. That's plus or minus that. Okay, so similarly too, if you decide to make sine square, sine A the subject of the formula, you realize that similarly that sine A will also follow suit, plus or minus square root of 1 minus cos square A. We have to go through all of this so that you can know the expression for cos A in terms of sine A and cos sine A in terms of cos A. Don't forget I said that angle is arbitrary. So look at it. It means that if I also want to get cos B, what will it be? Just change this A to B. That means cos B will be equal to plus or minus square root of 1 minus sine square B. And sine B will be equal to what? Plus or minus square root of 1 minus cos square B. It's as simple as that. So now, our duty now is to use this illustration to get the value for cos A here, and use it to get the value for sine A. Sine B rather. This is cos A, then I'm to use this to get I'm to use, I already know sine A, I need to know sine B. I already know cos B, I need to know cos A. So that's what I'm supposed to get. Alright, so permit me to rub out this. So what I'm going to do now is to quote this expression directly. So, but I just need to show you how we arrive at this. Don't worry yourself. Once you just follow suit, you don't need to write so much, just based on what you know. But if this is too long for you, you can quickly sketch your triangle if you know the method of using the right angle triangle. Alright, so look at it. This way I'm going to do it, because you will realize that we are going to need cos A and we will need sine B. Okay, in the expansion of this, I will not write this first. So permit me, you see me, I will have to rub this out now. And now work based on the fact that I already know what is required. So look at it. So I will say given sine A equal to 4 over 5 and cos B equal to 12 over 13. So look at what I'm going to say. I already know sine A here, but I don't know sine B. I already know sine A here. I don't know cos A, because that's what should be the complement of this. I already know cos B here, but I don't know sine B. Okay, so now look at what I'm going to say now. I will now say that, but okay, given this and this, where it's very important that you need to take note of this now. Okay, I think we can say it at the end, don't worry. So now, but cos A, okay, will be equal to square root of 1 minus sine square A. I hope you can remember. So now, can we put the value? So therefore, what is my cos A now? So cos A is going to be square root of 1 minus, what's my sine A? 4 over 5. Take note, sine square A is the same thing as sine A all square. So that means I can take the square of 4 over 5 for sine square A. So this will give me square root of 1 minus 16 over 25. And this will give me what now? This will give me square root of 16 over 25 is a proper fraction. So when I'm subtracting a proper fraction from 1, you don't need to waste your time to start doing LCM. Of course, that's also okay, but just as a fast approach, just subtract the numerator from the denominator. Whatever you get divided by the denominator, okay? So 25 minus 16 is 9. So the result of 1 minus 16 over 25 is simply 9 over 25. Suppose this were to be 2, okay? Just remove 1 from the 2, you'll be left with 1. Then 1 minus that proper fraction, just use that approach. Subtract the numerator from the denominator. Whatever you get divided by the denominator. It's just, actually, it's not a special method. It's like saying finding the LCM of 1, the denominator of this 1, and 25, which is going to be 25. 25 in 25, 1 in 25 is 25. 25 times 1, 25. Minus 25 in 25 is 1. 1 times 16, 16. So you realize that what is at the numerator is 25 minus 16, which is what we can still see here. So instead of going through that approach of looking for LCM, just subtract. The examiner knows what you are doing. Don't worry yourself, okay? So this is going to give me 9 over 25. So what is the square root of 9 over 25? Okay, and like we said, this will give us 3 over 5. But don't forget that we said that this is an even root, square root. Okay, so your result will not only be positive of this, it will also go with negative, because minus 3 square will also give us 9. Minus 5 square will also give us, minus 5 all square will also give us 25. So the result of this is going to be plus or minus 3 over 5. Alright, we keep that for cos A. But this is the issue now. Is it possible for cos A to be plus 3 over 5 and minus 3 over 5? No. That's the reason they gave, that was the reason they gave this condition, or this information rather, where A is obtuse. So what is the uniqueness or the usefulness of that information? If A is obtuse, then you remember your angles in the quadrants. In the first quadrant, you remember that all the trigonometric ratios are positive. In the second quadrant, only sine of angle is positive. In the third quadrant, only the tangent of angles is positive. In the fourth quadrant, only the cosine of angle is positive. You can easily remember casts. Okay, or all student takes coffee, whichever way that is easier for you to recall. So what that means is that in this quadrant, all the angles here are between 0 and 90 degrees. In this quadrant, the angles here are between 90 degrees and 180 degrees. In this quadrant, all the angles here are between 180 degrees and 270 degrees. In this quadrant, all the angles here are between 270 and 360 degrees. So for A to be obtuse, that means it's greater than 90 but less than 180. So if that is the case, it shows that that angle A will fall in this second quadrant. And once it falls here, take note, it is only sine of angles that is positive. Every other trigonometric ratios are negative. That shows that is cosine of angle positive here? No, because it is only sine that is positive here. So cosine of any angle in this quadrant will always be negative. The tangent of angles in this quadrant will always be negative. So A is obtuse. So definitely you can get what the value of cos A will be between plus 3 over 5 and minus 3 over 5. So look at me. I will say since cos A, since A is obtuse, therefore cos A equal to minus 3 over 5. I hope you got that now. Alright, permit me to rub out these parts and let me use this small place to get my value for sine B as well. So similarly, sine B, we also follow the same pattern. That's square root of what? 1 minus cos square B. So therefore sine B will become what? What will it be? What is sine B going to be? We have been given cos B to be 12 over 13. So we can insert directly 1 minus 12 over 13 all square. This will give us square root of what? 1 minus, what is the square of 12? 144. What is the square of 13? 169. So what is the subtraction of 1 and 144 over 169? You see that this is a proper fraction because the denominator is greater than the numerator. Just subtract this from this. Whatever you get over 169 is as direct as that. So this will give us, if I subtract this from this, 9 minus 4 is 5, 6 minus 4 is 2, 1 minus 1 is 0. So this will give me square root of 25, then divide by 169. Okay, and this will of course give me plus or minus what? 5 over 13. Now, sine B is plus or minus 5 over 13. Can it be the two answers? No. Now you go back to that information. B is acute. So since B is acute, you will need to remember, okay, B is an angle that is less than 90 degrees. So if that is the case, what is the trigonometric ratios of all the angles that are less than 90 degrees? You just remember cast all. Okay, that means all the trigonometric ratios are positive. So in that case, sine B can never be negative. The reason is that B is an acute angle. Do you understand now? So that means that I will say that since nígbà tí, B is acute, then what is sine B now? Sine B is equal to what? 5 over 13. Do you see how I eliminated minus 5 over 13? I used the given information, the fact that B is acute. Now we have to go through all of these procedures just to get our sine B and to get our cos A. I'm going to rub this out now, but I'm bearing these values in mind. So permit me to write it somewhere here so that I can remember. So I know my cos A. Let me write it somewhere here. Cos A is equal to minus 3 over 5, and sine B is equal to 5 over 13. Don't mind me, my own notes is filled up. I need to collect extra sheets, you understand? So I've just requested the extra sheets. I know you're asking me why am I rubbing out. Don't worry, it is the extra sheets. Okay, so now, we have, what do we have now? We have sine A equal to 4 over 5, comma, we have cos B equal to 12 over 13. We have cos A equal to minus 3 over 5. Then sine B, we have 5 over 13. So now, with these values, we can now evaluate our sine A plus B. Very easy. So now, what is now sine A plus B? Sine A plus B is sine A cos B plus cos A sine B. Very easy. So what will this give us? What is our sine A? 4 over 5. The operation between sine A and cos B is multiplication. Do you see it? Cos B is 12 over 13 plus, what is cos A? Minus 3 over 5. Oh, I understand. You might be confused here. So permit me to introduce a bracket to separate this sign from this, so that you will not carelessly go and say plus times minus, okay? So now, sine B is what? 5 over 13. The operation between this is multiplication. So you have this, then you have 5 over 13. Looking at it, is there any common factor between the numerator and denominator? No. So this result will be directly 48. Multiply the numerator, 48. Multiply the denominator, you have 65. Plus, okay. Plus, I think 5 can terminate. Oh, that would be true. But see something. Instead of me to terminate this 5 with this 5, do you notice that if I multiply this, I will have the same denominator as this? So I will not terminate it to make it easier. Of course, if you terminate, you will still get the same answer, but I will not terminate, I will leave it so that I can have the same denominator, and it will make my simplification of fraction very easy. I hope you got that. So this will become minus 15 over what? Over 65. Okay, it is now that this plus sign can now multiply this minus sign, so that I will have 48 over 65 plus times minus now will now be minus 15 over 65. So do you notice that the denominators are the same? So it will make it easier for me to be able to subtract the numerators directly, because they all have common denominator of 65. So 48 is just saying, or it's just like saying 65 in 65, 1 times 48, 48, minus 15 in 65, 65 in 65, 1 times 15, then I have 15. So what is 48 minus 15? You will realize that that will give me, that's 33 divided by 65. Can anything divide? No. So that's just the answer. 33 over 65. That is just one question. It's not actually difficult. It's just because we have to do this explanation. Okay? So that is for Roman figure 1. Permit me to rub it out while I take Roman figure 2. Now look at it. It is very easy, because once we have done the first part, okay, it will make our work for the second part very easy. So permit me to rub out this now. I need to see this. The moment you miss it here, there is high tendency of you missing it here, because tangent of an angle is also a function of sine of an angle and cosine of an angle, except if by coincidence you just stumble to get the right answer. Okay, so now we are done with Roman figure 1. Let's take Roman figure 2. I may have to rub out, but the final answer of sine A plus B is 33 over 65. Okay, all right. So Roman figure 2, we are still going to make use of this information. All right, Roman figure 2. From here now, I can imply. I'm going to do this implication sign because I will need it in this expression. So, but look at it. If sine A is this and cos B is this, cos A is this, sine B is that, what is now tan A? Tan A, by definition, it implies that tan A is equal to sine A over cos A. Right? So what is my sine A? It has been given to be 4 over 5. This is same thing as 4 divided by 5 divided by what's cos A? Cos A is minus 3 over 5. It's just very fast. Don't waste your time. The denominator of this numerator is 5. The denominator of this denominator is also 5, because at the numerator we have a fraction, at the denominator we have another fraction. So since the denominators of the numerator and the denominators are the same, okay, or is the same, which is 5, it will just terminate. Okay, well, anyway, I know maybe that's not clear. This is what I'm trying to say. We can rewrite this nonsense as what? This 4 over 5, this division sign, this is it. Then minus 3 over 5. And you know that the moment this division sign is being written as multiplication, then we have the inverse of this fraction. So this becomes 5 over 3. You see that 5 can terminate this 5. That's what I was saying here the other time. So which means the result of this is the same thing as minus 4 over 3. Now, the same ways Tan B, what will be tan B? Tan B will follow suit, sin B over cos B. What is sin B? Yeah. Sin B is 5 over 13. Then cos B is 12 over 13. Now, because you now know this thing better now, what I said here will now be applied here. 13 will just terminate this 13 because they are both at the denominator. Okay? So the result of this will just be, yeah, it looks like, oh, I thought there was a negative sign somewhere. Pardon me, please. So this will be 5 divided by 12. So 13 has terminated 13. If you follow the same pattern, we'll get this result. You just have to be fast. Okay? Now that we've gotten these two values, permit me to write these two now somewhere because I'm managing my space. Don't worry, I think I will get a bigger board someday to make the work easier for us. Alright, pardon me, let me write this somewhere, so I need to rub this out. So tan A is minus 4 over 3, and tan B is 5 over 12. So now I want to transfer it. We have this, so therefore tan A is equal to minus 4 over 3, comma, tan B is equal to 5 over 12. So now, what is the expression for tan A minus B? Anyway, except if I will do the proof of this in another video, but here I will just have to quote it. So this will give us tan A minus tan B divided by 1. If it is negative here, the next sign here will be positive. If it is positive here, the next sign here will be negative. That's just a way to master it. Tan A, then tan B. Alright, so our duty is just to substitute these values into this expression. And that makes our work easy. So this will become tan A is minus 4 over 3. This minus, this is it. Tan B is 5 over 12. Divide by 1 plus tan A is minus 4. I'm introducing the bracket, minus 4 over 3 multiplied by tan B is 5 over 12. So what will this numerator give us? You've got to be very fast, okay? So my duty, I want to do it straight away to make my work easy. Okay, let me put it here, equal to the LCM of these two denominators is 12. 3 in 12, that's 4. 4 multiplied by 4, that's 16. So because of this negative sign, I'm having a minus 16. Oh, you know, I said I'm doing it straight away. 12 in 12 is 1. 1 times 5 is 5. So minus 16 minus 5, that's going to be minus 21. So this result of this is minus 21 over 12. This division sign, look at it here. Okay? Now, the product of this, okay, 4 can go here, 4 can divide here. 4 here, 1, 4 in 12 is 3. So I'm going to have 5 over 9. So the result here is going to be equal to, okay, or let me do it this way. All of this divided by 1, I'm going to have minus 9 over 12. Did I say 9 over 12? Sorry, minus 5 over 9. So I'm going to have, this result will give us 1 plus minus 5 over 9. And plus times minus is minus, so this will give me 1 minus 5 over 9. Okay, so that's what I want to write here, 5 over 9. But like I said, what is 1 minus 5 over 9? 5 over 9 is a proper fraction. So just say 9 minus 5, that's 4. 4 over 9. So the result of this is going to be 4 over 9. So I have all of this as my expression. So my duty is now to simplify this. I can rewrite it. So this will give me minus 21 over 12. Then this one, I'm using multiplication now instead of division, but this will change to its reciprocal, which is 9 over 4. So what can divide? I think 3 can divide here, I have 4, and 3 can divide here, I have 3. So what is 3 times minus 21? I'm going to have minus 63 divided by what? 4 times 4, that is 16. Wow! That is just the evaluation of tan A minus B. So that's the final answer. I hope you gotten the solution to that question. We'll still have one more question in another year, and I think we'll solve that in the next video. I declare that every of the concepts that have been taught is retained in your cerebrum in the name of Jesus. I know it's not easy. You have tried your best. Don't be discouraged. You will definitely understand this topic very well. I believe when we take more questions and you see the approach with which we put solutions to them, it is easier to retain it. Just ensure that you maximize your time. Don't assume you have understood what we've done. Try as much as possible to go over it, practice them on your own, and see if you can, get the same results. In case you didn't understand any part, just replay that part and listen to it again that you don't understand. Feel free. You can drop your question. That part you don't understand that you feel, or maybe there are some other questions that you want to be solved and have never been solved, okay? Or maybe you are struggling with them. Just drop them in the comment section below as a question, and I'll try as much as possible to respond to those questions. The Lord bless you. I wish you success in your forthcoming Jupeb examination.